now, at this point in time, we're going to start discussing using local rulers and local clocks to measure cosmological events. We don't really look at things from an eye of God's perspective. We use our local clocks and our local ruler to measure events. So if local rulers are shrinking, which it'll give the appearance that distant rulers have expanded. If local clocks are speeding up, it'll give the appearance that distant clocks are slowing down. Now, again, as a reminder, the rulers are actually expanding and clock rates are slowing down since the rate of change from observable space is greater than the effects of unobserved space. But the observation of these effects of observable space were self-canceling due to dilation effects. So the only relationships we really observe are those associated with unobserved space. So our ruler is going to vary, and let's zoom this in a little bit. Our relationship of how ruler and intervals of time are going to measure when we look back in time should vary according to this relationship here. So we see clock rates slower in the past, and things should look a little bigger. Now this doesn't match and correspond to the dilation of space expected, so it's going to throw off cosmological measures that are dependent on that, and then such as Cepheid variable stars and so forth. But now, if we were to measure the size of a cosmological object, let's say a galaxy, and we thought we were going to look at its size, what it has, the observed angle size would vary. Basically, it should measure very initially the distance divided by the length, assuming it's far enough out to vary linearly, that the observed angle size would vary that by the size of the object divided by the distance. And then assuming it again is far enough away out that we don't have to worry about the sine-cosine relationships anymore. And then, but because of the expansion of space or the change of our rulers, the net effect of our rulers, we would have to change this angle size, the observed size, by this relationship. So if we plot how the image size should change, let's say the image, what we expect to see a galaxy, we would see it doesn't quite correspond to an object straight. If it's twice as far away, it should be 1/2 as big. The dilation effect from the use of our rulers, the variation of rulers, is throwing off these measures that we would observe. Now, and notice that the dilation effect does not match the stretch of observable space, which is going to throw off some of which is mentioned earlier. And let's see. And then